Hi, this is Manogna from Venkateshwara College of Engineering, second sem. Today I am going to explain about e-waste management and the subject is chemistry. Introduction to e-waste management in chemistry. Explore the critical role of effective e-waste management in the field of chemistry. Discover how proper disposal and recycling of electronic waste can minimize environmental impact and unlock valuable resources. Importance of proper e-waste disposal: environmental protection, resource recovery, regularity, compliance, public health. Environmental protection: proper e-waste disposal prevents the release of toxic materials like lead, mercury, and calcium into the environment, safeguarding ecosystems and human health. Resource recovery: e-waste recycling allow valuable metals, plastics, and other materials to be recovered and reused, Re- reducing the needs for new resources extraction. Regulatory compliance: following e-waste regulations ensures business and individuals avoid fines and regular penalties for improper disposals while demonstrating environmental responsibility. Public health: irresponsible e-waste handling can expose workers and nearby communities to hazardous substances, making proper disposal critical for protecting human health. Hazardous components in chemical e-waste. Chemical e-waste contains a variety of hazardous materials like that can pose serious risk to human health and the environment if not properly managed. This includes heavy metals, lead, mercury, calcium, and chromium found in circuit boards, batteries, and displays. Corrosive substances, acids, and solvents used in cleaning and etching process. Environmental impacts of improper e-waste handling. Improper disposals of chemical e-waste can have environmental consequences. Hazardous substances like heavy metals and toxic chemicals like leach into soil and groundwater, contaminating ecosystems and posing risks to human health. Improper incineration can release harmful air pollutants, further damaging the environment. Careless e-waste handling can also contribute to land and water pollution, distributing delicate new natural habitats and wildlife. Sustainable e-waste management and crucial mitigate these environment threats and protect the planet for future generation. Regulations and guidelines for chemical e-waste. Comprehensive regulation, international standards, labeling, and main fits. Comprehensive regulations. Regulations mandate proper handling, storage, and disposal of chemical e-waste to protect the environment and public health. These laws vary by region and industry. Industrial standards. Global organizations like the UN and EU have established guidelines for the management of hazardous chemical e-waste, ensuring particles across borders. Labeling and manifests. Detailed labeling and manifests are required to track the movement of chemicals e-waste for generation to final disposal and recycling. Recycling and recovery of materials from chemical e-waste. Chemical e-waste contains valuable materials like precious metals, plastics, and glass that can be recovered and recycled. Recycling these materials reduces the need for raw materials, conserves natural resources, and hazardous waste from landfills. Disposal methods for chemical e-waste: incineration, landfilling, solidification, chemical treatment. Incineration. Incineration is a high temperature control process and reduces the volume of hazardous nature of chemical e-waste. It can effectively destroy organic compounds and recover energy in the form of heat. Landfilling. Secure landfilling designed for hazardous waste can safely contain and isolate chemical e-waste from the environment. This method is suitable for material that cannot be recycled or recovered. Solidification. This process chemical e-waste into a solid, less permeable form to prevent leaching of hazardous substances. The solidification waste can then be disposed of in a secure landfill. Chemical treatment. Chemical treatment uses reagents to neutralize, oxidize, or reduce the hazardous properties of chemical e-waste. This can make the waste less toxic and suitable for disposal through other methods. Storage and transportation of chemical e-waste. Secure storage, controlled environment, transportation safety, tracking and documentation. Secure storage. Controlled secure storage. Properly store chemical e-waste in designed leach-proof containers. Segregate waste types to prevent hazardous reactions. Maintain proper and labeling inventory records. Controlled environments. Store e-waste in climate controlled, well ventilated areas away from heat sources. Ensure storage sites have spill contaminant and fire suspension systems. Transportation safety. Use approved carriers and manifest when transporting chemical e-waste, and ensure vehicles are properly placed and drivers are trained in hazardous material handling. Emerging technology in chemical e-waste management. Sensor based sorting, atomized bioleaching, etc. Sensor based sorting. Advanced sensor can preciously identify and sort different types of e-waste components, improving recovery and recycling rates. Automated. Robotic systems can effectively e-waste separating material for safer and more effective recycling. Conclusion and best practices. In conclusion, effective e-waste management is crucial. Minimizing the environmental impact of discarded chemical products. Adopting best practices such as proper disposal, recycling, and recovery of material can help protect our planet and human health. Stay include to regulatory guidelines, investing in emerging technology, and educating both consumer and industry on suitable e-waste handling. By working together, we can create a more circular economy for chemical products and ensure a cleaner, healthier future. Thank you for watching my video.